Hello students, we are in chapter 1, models, measurements and vectors. So far we discussed about units, unit conversions. Also we talked about significant figures. Next topic is vectors, vector components and vector addition. I have already explained physical quantities are divided into two categories, scalars and vectors. Okay, so any quantity that can be measured is called a physical quantity. Okay, so we use measuring devices to measure physical quantities. Okay, so any quantity which can be measured is called a physical quantity. Okay, there are several physical quantities. Some of them are scalars, some of them are vector physical quantities. Okay, now scalars have only magnitude but no direction. Okay, now vector quantities have both magnitude and direction. Okay, magnitude and direct. So whenever you specify a vector quantity, then you must specify magnitude, direction and unit. Okay, for scalars you will specify magnitude and unit. Okay, but no direct. So I have given some examples to you for scalar quantities. Examples are time, distance, right, density, area, volume, temperature, etc. So these are all scalar quantities, even speed. Okay, right. Now let's look at vector quantities examples. So displacement, velocity, acceleration, force, momentum, torque, okay, etc. Okay, you're going to learn about all these quantities in the rest of the chapters. Okay, now so we are focusing on vectors now. Okay, now let's look at vector components. Right, so what are vector components? Suppose you have the coordinate system. This is positive x, positive y here. This is the origin. Now any vector can be resolved into two component vectors. Those are x component and y component. Okay, let's consider an example. Let's say this is vector a here. Okay, so this is the symbol we use to denote vectors. So let's say you have a vector a. Okay, so you will write letter a and with an arrow mark above the letter. Okay, so this is the notation to indicate vector a. Okay, now also to graphically represent a vector, you draw an arrow. So this is the tail of that arrow and this is the tip of that arrow, right? So tip and tail. Now the length of the vector indicates the magnitude of the vector. Understand? So this is the graphical picture. Okay, so magnitude, and the tip indicates the direction. Let's consider two vectors. Let's say you have vector a here and let's say you have vector b here. Understand? Now obviously you see the length of vector b is greater than length of vector a. That means the magnitude of vector b is greater than magnitude of vector a. Okay, so to write the magnitude of vector a, we use this symbol. Okay, so this is the symbol to write the magnitude. So okay, now and for magnitude of b we put the arrow mark and also this pipeline symbol here. Okay, now absolute value. Now suppose you want to sketch, let's say, negative a. Okay, so you are given vector a like this and you need to sketch negative a. Okay, so negative a means you are sketching same magnitude but opposite direction. You see the negative sign? So same length, same magnitude but opposite direction. So this is negative a. Understand? Now suppose you are asked to sketch twice the magnitude of a, then you will draw a vector that is double than that. Understand? So this is 2a. Clear? Now suppose you need to sketch negative b, that means you will sketch exactly opposite to this vector, same length. Understand? So this is negative b vector. Clear? Suppose you need to sketch negative 2b, then you will sketch a vector double than this one, which is this vector. Understand? So right, so that's about 2b. Okay, right. So suppose if the vector is at an angle, then also you will do the same thing. Okay, so that's negative a. Now let's look at vector components. Okay, so what are vector components and how do you find those components? Suppose you have a vector a making an angle theta with the positive x-axis. Okay, so we are always measuring angle from positive x-axis, remember this. Okay, we go counterclockwise for positive angles, counterclockwise for positive angle, okay, and clockwise for negative angle. Understand? So remember this. We go counterclockwise from positive x-axis for positive angle. So let's say you have vector A making a positive angle with x-axis, right? So this vector A it has some magnitude and it has some direction, and this theta representing the direction, right? So theta A gives us direction of vector A. Understand? Okay. Now this is the magnitude of vector A. So we said any vector can be resolved into two component vectors. Those are Ax and Ay. Clear? Ax and Ay. So Ax and Ay are the component vectors, components of vector A. We should know how to calculate these components. Okay, so Ax and Ay. Okay, so how do we calculate these components? Also, you need to know how to find out the magnitude of vector A and the direction of vector A. Okay, so how do we calculate components of a vector and magnitude and direction of a vector? Okay, now so resolving this vector into two components x and y is very important for us. So this vector A is not along x direction or y direction, but it will be easier for us if we can find a vector component that is pointing along x and y directions. Okay, to find the components Ax, we will use this formula, magnitude of A times cosine of the angle. Okay, so cosine of the angle that vector A is making with x-axis. And to find out the y component of the vector, we use sine of the angle times the magnitude. Okay, so this is the simple formula. Okay, so we get this formula from the definitions, trigonometric functions, sine and cosine. Okay, so you can imagine the right angle triangle here, and you can apply sine and cosine to get these equations. Okay, now the magnitude formula is square root of ax square plus ay square. That means if you know the components of a vector, you can easily find the magnitude of the vector. Okay, now to find the direction, we use inverse tangent of ay component divided by x component of the vector. Understand? So these four are very important equations in this chapter. Okay, now if you know the magnitude and direction of a vector, you can easily find the components. If you know the components, you can easily find magnitude and direction of a vector. Okay, now these formulas are in your formula sheet. Let's do some problems. Okay, this is problem number 39 in the textbook, chapter 1. At the end of each chapter, you have list of problems. Okay, so in the textbook, read the chapter, and at the end of the chapter, you have summary and some problems. Okay, so I'm choosing those problems here to explain you. Okay, now problem number 39. A woman takes her dog Rover for a walk on a leash. To get the little dog moving forward, she pulls on the leash with a force of 20 newtons at an angle 37 degrees above the horizontal. How much force is tending to pull Rover forward? How much force is tending to lift Rover off the ground? You see the two questions here. Now, so this is x-axis, this is y-axis here. Okay, so the dog is at the origin, for example. Understand? And a woman is pulling that dog with using a leash, right? So takes her dog Rover for a walk on a leash. To get the little dog moving forward, she pulls on the leash with a force of 20 newtons. Okay, this N is the newtons, which is the unit of force. Okay, we will understand more about forces in chapter 4. Okay, now so this is a force vector here. Understand? And this is making an angle 37 degrees here. Okay, now the magnitude of the force is given to us, which is 20 newtons, and the direction of force is 37 degrees. The projection of this force vector along x direction is fx, and the projection of it along y direction is fy. Now the first part of the problem is asking for how much force is tending to pull rover forward. So how much force the dog is experiencing in the x direction, that is Fx. Understand? So that's the first part. And the second part is how much force is tending to lift the rover upwards. So this is the upward force, y component of the force. You remember from the previous slide you learned how to calculate x and y components. So this is magnitude of force vector times cosine of the angle that force is making with x-axis, and this is magnitude times sine of the angle. Clear? So we know the magnitude and direction. Simply substitute these values here and you will get the fx and fy values. So very simple problem, but draw diagram and carefully write down what is given in the problem and you find the correct equation to solve the problem. Also make sure you do the correct calculations. We are finding here x and y components of the force. So when you are pulling a dog with certain angle with the leash, then the dog is experiencing a forward force and also a force off the ground, vertical direction. So actually the dog is feeling little inconvenient when you pull it at an angle. Okay, so here are the components, right? So the answers for this problem are at the end of textbook. Okay, so you can check that. Now next problem, vector addition problem. Okay, so now in this problem we are adding vectors. Okay, now let's learn how to add vectors before we do this problem. Okay, now there are two different ways you can add vectors graphically. So graphical procedure. So the first procedure is tip to tail method, and the second procedure is parallelogram method. Very simple procedures. So tip to tail procedure means you just go from tip to the tail of the second vector. Okay, let's say you have two vectors. This is vector A and let's say this is vector B. Understand? Now so you are adding these two vectors, that means you are finding sum of these two vectors, A plus B. Okay, so that means you will get a resultant. Okay, so let's take vector A and join the tail of the second vector to the tip of the first vector. So this is vector B here. Understand? So tip going to the tail. Okay, now from the tail of the first vector, if you draw a line, okay, so that will be the resultant. Understand? So this is the vector, resultant vector, so that is equal to A plus B. Understand? So very simple method, that's tip to tail procedure. Okay, now let's look at parallelogram procedure. Okay, so in parallelogram procedure, so this is all tip to tail. Okay, now in parallelogram procedure, let's consider same two vectors A and B, and you are adding these two vectors. Here you need to construct a parallelogram. Okay, so let's take vector A here, and now you need to add vector B at the tail of the first vector. Okay, understand? So this is vector B, this is vector A. Now sketch parallel vectors to these two vectors. Okay, so this is a parallel vector to B, this is a parallel vector to A here. Now the resultant will be the diagonal here. So this is the resultant, which is A plus B vector. Now the important thing is the both methods, tip to tail method and parallelogram method, both give us the same result. Understand? You can see here same direction, same magnitude here. So both methods will give you same answer. Okay, now here you need to construct a parallelogram by sketching the parallel vectors. Okay, parallel vectors means, suppose you have vector A, a parallel vector to A is must be same magnitude, same direction, but at a different location. So this is a parallel vector to vector A. You can call it A prime. Clear? So that's the meaning of parallel vector. Same magnitude, same direction, but at a different location. Okay, so these are the two different methods. Okay, so this is the graphical procedure, you add vectors. Now let's learn the analytical procedure to add two vectors. Now here I gave you the example of adding two vectors, but if there are more than two vectors, you proceed in the same way. Okay, for example, you have, let's say, another vector C here in this direction. Okay, now in this case what do? You can just take A and then B here, and then C here. Understand? So this is A, this is B, this is C. Okay. Now the final resultant vector in this case will be, so always from the tail of the first vector to the tip of the last vector, that will be the resultant. Understand? So suppose you have more vectors, you again do the same procedure. Understand? You just sketch all the vectors following tip to tail, and finally from the tail of the first vector to the tip of the last vector. Okay, one more important point is the order you add vectors doesn't matter. That means A plus B plus C must be equal to C plus A plus B, or B plus C plus A, and so on. You understand? So you can add vectors in any way, in any order, you understand, but all of them should finally give you the same result. Next topic is how to add vectors analytically. Analytic procedure. Okay, now let me take two vectors, okay, and then explain you how to do it. So let's say you have two vectors A and B with magnitudes and directions. You want to find out what is the resultant, which is A plus B. Okay, now this resultant is also a vector quantity, so it must have magnitude and direction, right? So this is formula Rx square plus Ry square. You remember from the previous slide, to calculate magnitude of any vector we use this formula. Okay, this is in your formula sheet. Direction is inverse tangent of Ry divided by Rx here. So now our job is to find out Rx and Ry, because once you know Rx, Ry, you can easily find the magnitude and direction of the resultant. Now how do we find the x component of the resultant and y component of the resultant? See, from this vector A, you can resolve this into two components, ax and ay, and this is also this is bx and by here. Okay, right. Now to find Rx, we just add all the x components of individual vectors, and to find Ry, we add all the y components of the individual vectors. So once you know these Rx and Ry values, you can just plug in these equations to find magnitude and direction. Okay, right. So this R is the resultant, which is sum of A plus B. Okay, now you need to be careful here. We said resultant is sum of A plus B. You cannot just add the magnitudes of A and B here, because these are vector quantities. You must consider the direction, and that means you must consider the angle that these vectors are making with x-axis. Okay, now you see here ax value, ax and ay is cosine of the angle that vector A is making, and magnitude times sine of the angle that vector A is making. Okay, so this is how you find the ax, ay. You see, magnitude and direction both matter when you calculate the components. Understand? So that's why you cannot add A and B magnitudes, because you need to consider the directions also. Okay, right. Now let's solve this problem, example problem. This is already solved in textbook. Okay, page number 18. Now but I'm explaining it here step by step. So in this problem, it is given that vector A has magnitude of 50 centimeters and the direction is 30 degrees. Okay, now vector B has magnitude of 35 centimeters and the direction of 110 degrees. Understand? So counterclockwise positive angle 110 degree. Both angles are measured counterclockwise from positive x-axis. Use components to calculate the magnitude and direction of vector sum. Okay, so that means we are calculating the vector R. Okay, that means we are calculating magnitude of R and direction of R. Okay, so once we get these two, that means we got this. Understand? Right. So let's follow the procedure. Okay, now find out what are ax and ay values. Okay, so magnitude of A times cosine of the vector A. Okay, so that is 50 centimeter times cosine of 30 degrees. Understand? So you get in centimeters. Similar, ay is sine of the angle, so this is 50 centimeter times sine of 30 degrees. Okay, so you will find these values. Similarly, find bx and by values. So this is also in centimeters here. Okay, now so I got ax value 43.3 centimeters, by value 25 centimeter, bx value negative 12 centimeter, by value 32.9 centimeter. Okay, now so if you find rx, which is ax plus bx, okay, so that will be equal to 31.3 centimeters, and ry is adding all the y components of the individual vectors, 57.9 centimeters, right? Okay, now the only thing left is to find the magnitude. Okay, so this is equal to square root of 31.3 centimeter square whole square. Okay, use parentheses, 57.9 centimeter whole square. Okay, so this will give us 66 centimeters. Okay, now the direction of r is inverse tangent of ry divided by rx. Okay, so that's the inverse tangent of this number divided by this number, right? So 57.9 centimeter divided by 31.3 centimeter. Centimeter gets cancelled, and when you solve for this, you will get 62 degrees. Understand? So this is our final answer. So you get magnitude and direction of the resultant. Okay, let's draw this here and see what you get. So this is the axis. Okay, so this is x-axis, this is the origin, this is the y-axis. Okay, and this is the negative x-axis here, right? Now vector a is 50 vector a is how much? I think that vector a is 50 centimeters, 30 degrees. So that's vector a. So this is 30 degree here. So graphically I am sketching this here. Okay, figure is not to the scale. So this is 50 centimeter. Now vector b is 110 degrees and 35 centimeters. So let's say that's vector b. Okay, and this is the x-axis 0 degrees. Understand? And this should be around 110 degrees. Okay, actually should be 110 degrees. Okay, but I'm drawing a rough diagram. But actually when you're sketching this on a graph paper, you must use the protractor here, okay, to measure it 110 degrees. Now the resultant will be, I'm using tip to tail method. You see the tip of the first vector joined to the tail of the second vector. Okay, now the resultant is from the origin, if you from the tail of the first vector to the tip of the last vector. Okay, so now this is the resultant, and its magnitude is 66 centimeter, its angle is 62 degrees. So this should be 62 degrees. Understand? Right. So this is our diagram for this problem. Okay, so this is graphical representation of vector addition, and this is the analytical procedure using components. Okay, so this is using components, you are adding vectors. So this is how we add vectors. So we covered most of chapter 1 concepts. Let me know if you have any questions. Okay.